Hello everyone. Okay, this video will show you the solutions in estimating the hydraulic conductivity based on two equations or based on two methods, which is the first method is by Carrier and the second method is by Chapius. Okay, as you can see here, the questions mentions that the figure shows the grain size distribution curve for a sands. Okay, that has been obtained from the site investigation report from construction site. By considering the void ratio, okay, it mentions that the void ratio, there is the E value 0.6 and the shape factor SF is 7. So you need to determine the hydraulic conductivity is K. Okay, remind to all, when we try to calculate the hydraulic conductivity using this Carrier and Chapius is only applicable to granular soil. Okay, as in our case, it's referring to sand. So sand is categorized by granular soil. Okay, so if you are conducting for clay and so on, you need to referring to another type of equations. Okay, the first step when we get this type of questions or this type of example, you need to extract all the data. Okay, how do you extract all the data? By referring this point. Okay, this point means that the sieving size yang you guna during the lab session. Okay, so the first one is for 100%. So you will get this size. And then for 96 or 96 here. Okay, and then you get here. And then this one, it may be 84. You get maybe here. And then this one is percentage passing is 50. You will get here, and then 0% passing is at 0.775 here. Okay, and this one is maybe 0.15. This one is maybe 0.25, 0.4. This one is like let me check first. 0.425, and this one may be around 0.6. Okay. So you will get the data. The exact data is X is in mm, okay, and Y should be in percent. Okay, before we proceed for our next solutions is, remember in this axis is mm. Okay, the unit is mm, but for Carrier and Chapius it should be in cm per second. The value is K. So before you substitute all the data or all the parameter into these equations, you need to convert the grain size in mm unit to centimeter unit. Okay, so for the first one is okay, 0.06. This one is already converted to okay, cm. 0.06, 0.0425, 0.025, 0.015, 0.0025. Okay, there is 0% passing, and then 1 to 5 is 50% passing, and this one 84, 96, and this one is 100% passing. Okay, so all the data you need to use in the next step. Okay, now there is the next step in calculating the hydraulic conductivity or the K. So the first one is you need to put as a sieve number here, sieve number, and then there is the sieve opening or maybe you can use the diameter, sieve diameter. Okay, don't forget we need to convert it to centimeter. Okay, previously you get from the curve is mm, so convert into centimeter. And then this one is the percentage passing. Okay, and then the last one is the fraction of particle between two sides. Okay, this one is Fi, so in percent. Okay, so the first one, as I mentioned previous, we have sieve number 30, 40, 60, 100 and 200. Actually, there are no effect to your calculations. If you want to put as a sieve number 1, 2, 3, 4 and 5 and so on, it can be as long it didn't affect to your calculations. Okay, and then the sieve opening, when you are already convert to centimeter. Okay, this is in centimeter. Okay, 0.06, 0.0425, 0.02, 0.015 and then 0.0075. Okay, the percentage passings, this one. Okay, so this passing, so 100, 69, 84, 50 and 0. Then the fractions of the particle between the two consecutive sides is, how do you calculate is 100 minus 296 is equal to 4, 96 minus 284 equal to 12, 84 minus 250 equal to 34, and then 50 minus 20 equal to 50. So this is 0. Okay, so you will get this type of data actually. Then you can substitute all the parameter of all the data in these equations. Okay, in this equation. So you will get the K. Alright? Okay, now we can calculate our K based on these equations. Okay, before that, the critical part here is in this bracket. Okay, in this bracket. Okay, there is the shape factor, there is the void ratio. Okay, what is the difference between DLI and also DSI is DLI is for large sieve, large size of sieve. DSI is for small sieve. Okay, for the example is for sieve number 30, because it mentions that the fraction of particle between two consecutive sides. So let's say we have sieve number 1 is 30, sieve number 2 is 40. So you see the opening size of the sieve is 0.06 and 0.0425. So which one is the larger sieve and also which one is the smaller sieve? So of course the 0.06 is larger than 0.0425. So 0.06 is your DLI. Meanwhile, the DSI is 0.0425. Okay, so that one is how do you differentiate between DLI and also DSI. So in this case, you have between two sides of opening. So you need to have 1, okay, and then 2, 3, and 4. Okay, so you have Fi1, Fi2, Fi2, Fi3, and also Fi4. Since there is 0, so we have 4, 12, 34, and also 50. So we try to substitute in our equation. Okay, in solving this part first. Okay, fractions between numbers 30 and 40. Okay, Fi equal to divide by DLI 0.404 times 2 DSI 0.595. Okay, so Fi is 4. There is our Fi. Okay, fraction. There is Fi. Divided by DLI is larger, so 0.06 power of 0.404 times 2 0.0425 power of 95. Okay, so you will get 81.62. Meanwhile, for fractions between number 40 and 60, okay, same equation, okay, same equations, but you have 12 divided by 0.0425 power of 404 times 2 0.02 power of 0.595. So you will get 440.76. Same goes to fractions between number 60 and 100. Okay, equal to 34 divided by 0.02 power of 0.404 times 2 0.015 power of 0.595 equal to 2009.5. Okay, and then we have another one, fraction between 100 and 200. So 50 divided by 0.015 power of 0.404 times 2 0.0075 0.595. Okay, so this one you get 5013.8. So this one and also this one should be summed up for this one. See, this one is the summation or the total of Fi. So that's why you need to calculate one by one. Later on, baru you boleh 100% divide by this total power of 2. Okay, so later we go to the next step. Okay, after you get all the fraction value Fi for each 2 consecutive size sieving opening, so we can proceed for calculate the K value. Okay, so the SF is given in the equations here. SF is in our case, our shape factor is equal to 7. Okay, and then our E void ratio is equal to 0.6. So you can calculate the K is equal to 1.99 times 2 power of 400 divided by 81.62 plus 2 440.76 plus 2 2009 plus 2 5013.8. Okay, power of 2 and 1 over 7 power of 2 times 2 0.6 power of 3 divided by 1 plus 0.6 here. Okay, so your K value should be equal to or approximate to 0.0133. Okay, so this is your answer for hydraulic conductivity by using the carrier. Okay, next we will go to the second equation or second method. Okay, these equations or this method is straightforward method or straightforward solutions, but the important is in this method you need to determine what is the D10. Okay, as I mentioned in the class or during the lecture, the D10 is the effective size that we use when we are conducting the sieving analysis. Okay, the effective size that we use. Okay. Okay, so where is the location of the D10 is? The D10 is means that the diameter at 10% passing. Means that our 10% is here. There is our 10. So you go horizontally to the curve. So you get here and then you go to the x-axis to get the grain size. Means that the diameter for 10% passing. So there is the effective size that you will use in your analysis and so on. Okay, in this case, our D10 is equal to 0.09. It's okay if you get plus minus 0.05 because it's based on the individual judgment, so I not fix the value. Okay, so it let's say 0.09, but this one is in mm, so you need to convert. There is in cm. Okay, so you need to convert to centimeter. So 0.9 centimeter. Just substitute all the parameter into this equation. Okay, so 0.9 square. Okay, square times 2, our E is 0.6 divided by 1 plus 0.6. Okay, and then all this one is 0 power to 0.7825. So your value should be 0.436 centimeter per second.